All right, so if we have a function that looks like this, absolute value of negative, or f of x equals negative absolute value of x plus 1. So your first step is to set what's in the bars equal to 0. So like just what's inside. So x plus 1 equals 0. So negative 1 is going to be the vertex of our v, like the pointy, sharp part of our v. Okay? So negative 1 is in our middle. Right, so then I'm going to count backwards from negative 1 to get some numbers above it. So I'm going to go like negative 2, negative 3, negative 4. Okay, then I'm going to count forward and get some other numbers. So like from negative 1, then you count to 0, 1, and 2. Okay, so that's like how you get those x values. Hey, those lines actually turned out way better than I expected them to. Okay, so now what we're going to do is we're going to plug all of these numbers in to this, right? And I'm going to write that out so you guys can see how I'm talking through that. Yes?
Do you always go like backward, up, forward, down?
Yeah, but as long as you get them all in there, it doesn't matter what order you do it in. Like, I could have put my 0, 1, and 2, and then my negative 2, 3, and 4 here. It doesn't matter. As long as you end up with those numbers, then it's fine. Yeah. Yeah, you're good. Okay, so... Oh, nope, not what I needed. I wanted to, like, make my chart look a little better.
My pin's not working. Can I do some?
Yeah, there's some up here. All right, so I'm plugging in negative 4. So it's negative absolute value of negative 4 plus 1. So, negative 4 plus 1 is negative 3. What's the absolute value of negative 3? 3. But we still have this negative in front, right? So our answer is negative 3.
Why do you have two separate ones? So you have...
All right, so look, negative absolute value.
Never mind, you just worked it out.
I did.
Yeah.
Right, so I've got negative 4 plus 1 is negative 3. Absolute value of negative 3 is positive 3, right? And then this negative is what's right here. Okay? So we lost the one inside because of the absolute value. We keep the one outside. So that's how our answer stays negative 3. Okay? So when x is negative 4, our function is negative 3. Right? And I picked this one because I noticed the ones where we've got those negatives outside really tripped a lot of people up. Okay? So then we're just going to keep doing that with all these other numbers. So now instead of negative 4, I'm plugging in negative 3. So negative 3 plus 1 is negative 2. Absolute value of negative 2 is positive 2, but we keep that outside negative, so our answer is negative 2. Right, and then we do it again. Negative 2 plus 1. So it's negative, absolute value negative 1, which is negative 1. And negative 1 plus 1 is negative 0, which is just 0 because 0 can't be negative or positive. It's just 0. So does seeing it that way help? Right? If you guys need to, get a sheet of paper on the test and take the time to write it out and plug it in. If that is going to help you get it, okay? Okay, so then when we plug it, I'm going to shrink that a little bit if it'll let me. Oh, I don't want to shrink all of it. Just that. Oh, okay. We'll keep that one big, I guess. right, so then when we plug in 0, you get negative absolute value of 1, which is just negative 1. So remember, absolute value, if it's a positive number, it stays positive. If it's a negative number, it's positive. So like the absolute value of positive 2 is just positive 2, but we still stick that negative from the outside there. Right. So now we have the points we need for our graph. Okay. Did this help? Yes? No? Huh? Well, yeah. All right, so then I'm going to kind of shrink that a little bit. Is that okay with everybody? Do we need it bigger for a second? Peyton, you good? Can you see that? Okay. I'm going to ask you if you can see all the time now because you told me you won't wear your glasses. And I do that because I love you and I want you to have the eyesight you need to do well. Okay. So then we're graphing. Oh, I hate drawing my own graphs. Please hold. How do I want this. What's that? Colors and patterns. No. Ew. I don't want that. Whatever. I'm drawing my own graph. Why won't you let me? I don't know what's happening. Okay. It's fine. So then I'm kind of making this big so I have room, but that was a really bad job. 1, 2, 3, 4. 1, 2, 3. Okay, so when x is negative 4, that means I'm going to go left 4 and down 3. And put 1 dot of my v. Then I'm going to go left 3 because it's negative and down 2. Then left 2, down 1. And then left 1, 0. And then at 0, I'm down 1. 1 down 2, 2 down 3. So left, stay, right, right. Down, down, down. Okay, so notice I have an upside down V. Okay. If you're not sure if it should be upright or upside down, right? If you have a negative in front of your absolute value, if you have this right here, that big red negative sign, that means your V is going to be facing down, right? So if you've graphed it and your V is not facing down, that means you've messed up somewhere and you need to go back and check your numbers. Okay? How do we feel? Good? Okay.
I need one with, like, with a number outside of the absolute.
Okay.
You know what I mean?
Yep. So like if you're like subtracting something from it?
Or adding.
Yeah, okay. Okay.
And, like, basically the same thing as that, just with the outside.
Huh?
Same thing that we just did, but with the number outside the absolute.
Yeah, come show me. Okay, so now that we have that, we're going to start working these out. Right, so I'm going to kind of go up here. So then I have 2 times negative 3 in my absolute value bars, and then I add 3. So 2 times negative 3 is negative 6. Absolute value of negative 6 is 6. So it's 6 plus 3, which is 9. Okay, then we're going to plug in negative 2. So 2 times negative 2 plus 3. So that's absolute value of negative 4 plus 3. So 4 plus 3, which is 7. All right, then again with negative 1. So that would be 2 plus 3, which is 5. Okay, then with 0, 2 times 0 is 0 plus 3 is 3. Right, and then especially if you have like the same numbers, opposite signs over here, that's when you can tell, hey, this is going to repeat. Like it's going to do that. But let's check it anyway. So 2 times 1 in the absolute value plus 3 is 2 plus 3, which is 5.
When you have the same numbers that are negative and positive, they just start over.
For the most part, yes. Especially if you have like a fraction and then you've picked some different stuff, you really have to watch that. But yeah, really, they should, if you're picking the stuff like the same distance from your vertex, they should have that pattern. So like I should get 5, 7, and 9. Because 2 times 2 is 4, plus 3 is 7. And then 2 times 3 is 6, plus 3 is 9. Right. Micah, was that helpful? Okay. So then,
I think that was like not changing the sign. That's okay.
okay. Yes, that'll do it. All right, so then let's graph it. So will this one open up or down? Up, right? Because there's not a negative right here. Yes, I'm kind of spreading this out. 1, 2, 3, 4, 6, 7, 8, 9. Haha, look at that. All right, so then I'm going to go left 3 and up 9. That's higher than that. All right, you guys have graph papers, so yours will look better than mine probably. I shouldn't have spread those out that much. Hold on. That's going to bother me. And my 1 started up too high. Yeah. 1, 2. Oh, because mine wouldn't have showed the same shape as yours. Okay, so 3, 9. Because I added 1. Negative 2, 7. 2, 3, 4, 5, 6, 7. 1. Negative 1, 1, 2, 3, 4, 5. 0, 3. So then, so it should be a little bit more narrow than the last one we drew. Going upwards. So, do we feel more comfortable with the absolute value? All right, now I want to do one of the piecewise functions. Okay. All right, so let's start here. So -4 is where I'm going to decide if I keep stuff to the left or to the right of it, right? Correct, I should say, because I'm talking left and right. 1, 2, 3, 4. So if it helps, I'm going to just like take a color and I'm just going to draw me a line there. So I know that I'm going to keep stuff either over here or over here. So since this less than sign is pointing that way, I know that for this one, I'm going to keep everything to the left of that -4. So that equation is going to go over here. I'm going to graph the whole thing, but then when I go to erase, I'm keeping what's here in this green chunk I'm making, right? And I'm getting rid of everything else that's not in the green.
What's that line? Is that just showing?
That's just showing me that -4. I drew that so it kind of just looks like a barrier. So we know where to keep and where to not keep. So I would do that in like a different color than what you're graphing in. If you want a highlighter, Mike, I can toss you one. But yeah. Yep. Just give these back. These are my good ones. Ooh. Nice catch. That was great. Okay, so yeah, so I would draw this line in highlighter at least. Okay. So you're looking at this, -4.
So I'm looking at
So, like,
everything back.
Yeah, so like for this equation, I'm gonna graph the line like normal, but I want to make sure I extend it, and then I'm only keeping what's inside the green. Let me get to that part and I'll show you. Okay, so I'm going to now graph the equation -3x plus 2. So that's just a line. We don't have to fill out one of our charts, right? So that's where we have our y-intercept, which remember goes on our y-axis. Okay, and then we have our slope, right? So in this case, it is -3/1. So we can go down and right. I think for this one, it's also going to be very helpful to go up and left, right? You can do either one. So you can go down and right or up and left for a negative slope, right? But first we plot our y-intercept, which is +2. So since I need it to go left, I thought I was on the laser pointer. Since I need it to go this way, I'm going to go up 3 and left 2 and just keep doing that, okay?
So it's down and right, up and left.
Down and right or up and left for negatives, yes. So I'm going to go 1, 2, 3, 1. 1, 2, 3, 1. There's not very much of this. I should have picked something other than 4, but here we are. So normally you're not going to like have it's not going to be as dramatically far up as what I just did. This is what happens when I make up. Should be way up there.
Oh,
Right. Again, normally on a test there, I picked them out much more neatly. So like I should have picked like -2 and then we could have kept some more. I'm sorry. I know. Mine's going through my problem too. So again, huh?
I go down.
I mean, you can. Okay, so it's
Where did you pull the negative?
right here. What's in front of the X?
So, oh yeah, that's your slope.
Mm-hmm. So it's all the way up there, which is kind of a pain in the butt. Sorry. This is what happens when I make up math on the fly. All right, so then we're going to do our absolute value one. All right, so we should get a V. Okay. So just like before, set what's inside equal to 0. And that's our middle.
So you're gonna do the chart.
Yep. I know I'm going kind of quick. I just want to make sure I get through the whole thing. And like I said, I will send this video to everybody. I will make sure I sit and upload it and send it before I go to lunch. Okay? So then you get 2, 1, 0, 4, 5, 6. So this is kind of like the first one we did where we've got that negative on the outside. Right? I don't really have the space to write them all out like I just did, but let's talk through them, okay? So I have 0 minus 3, right, which gives me a negative 3. Absolute value is positive 3, but then make it negative. So it's still, when x is 0, it's negative 3. At 1, I get 1 minus 3 is negative 2. So it stays a negative 2. At 2, I get negative 1. At 3, I get 0. And then it's going to do that nice repeating process for us.
Where you keep it negative?
Yeah, because that's like telling you how far down to go. So it's like 0, negative 1, negative 2, negative 3. That's what makes the V. Right, so then when x is... I'm going to erase some of these dots I had from my other line there. Oh, no. Okay, so when x is 0, y is negative 3. So here, at 1, I am at negative 2. What? 3, 0, yeah. 4. Hold on, I missed something. What am I doing? Negative 3. 1, negative 2. 2, negative 1. There it goes.
Whoa. Mine's longer on hold on.
What?
Mine's fine, never mind.
So when x is 0.
Oh, I wasn't the wrong way.
Okay. Right, so then, everybody else with me? So, especially when you guys are doing these piecewise graphs, you really should extend them as far as they can go. I guess really that shouldn't have an error. That'll have like that closed-in circle there. But,
Oh, you in the end of the segment?
yeah, because it can't go, it can't extend through here because it's not over there, right? Since it stops at 4. So if it, on that line there, it would extend. Like this side is an arrow, but. So your graph would look something like that. Okay. So do we feel like we are in a better place to do some corrections tomorrow?
Right. Wouldn't it be a circle not filled in? Does it equal to?
No, because it's got the or equal to is where it's filled in. All right, and then if it's not that, it's an open circle.
Like circle.
Like on the ends of this. Like fill in the dot here.
We gotta like open like.
I mean, you should. I'm honestly not as worried about that for tomorrow. We can come back and address that issue another day. But
Are you supposed to? You're supposed to erase everything on this one?
no, not for this one. Like you would erase, and if you had extended your graph this way, you would have erased what was in the green for the second part.
You don't do that for the.
No, you don't need to because we didn't draw anything over there. Okay. I will send this to you guys. You can so make yourself a page of notes that you guys can use to do your corrections tomorrow. Okay. So just fit it on a page, whatever you need. Like I said, I will send this video to you, so you have it to look back at. And we will do some corrections tomorrow. All right. Okay, that's all I got. You guys are free to go to lunch.